What's going on, guys? We have this question right here. It's asking, let A be a n by m matrix so that the set of all vectors x in Rm where Ax is equal to 0 is a subspace of Rm. So first of all, this is actually a null space question. The equation is null space equation. Ax is equal to 0. So they have given this n by m matrix and we have x. So this is going to be m by 1 and the answer will be 0, right? 0 n by 1. So then what we have to do is we have to, so they are asking so that set of all vectors in Rn where is a subspace of Rn. So to show this, to show anything is in subspace of Rn, we have to have, it has to fulfill three conditions. So first of all, it has to have a zero element. The second one, it has to be closed under addition. And the third one, it has to be closed under scalar multiplication. So to prove the first one, I have to simply substitute 0 for each values. So if I substitute 0 for a and 0 for x, I will get 0 0 0. Therefore it has a 0 element. So it's going to be 0, it has a 0 0, therefore it passed the 0 element test. To, the second one is asking whether it is closed under addition. To show that, I take two, or let's say a. So we have to grab, let's say, okay, let's see. So if I take a1 and let's say a2, a until ak, right, whatever the value, then in bottom I take a2. So let's say this a prime 2, a prime k, a2, a until ak. So if I take this value, so for if this is true, then this should be true. This would be ax equal to 0. If I take this one multiplied with the x should be equal to capital 0. Then to prove that it's closed under addition, I add another one. Actually, I take the exact same one and add, then see if it's true. So a1, a2, a prime k, or you can take a different one too. It's gonna still give the same answer. So let's see. So in this case, if this is true, then this would be like, this will be also ax. This is same thing. And if this is true, then if I add both of them, I will get 2a1, 2a prime 2, 2a prime k, and this is gonna be 2a2, 2ak. So if this is true, if I multiply these two, it should give me 0. If I multiply this one by x, it should give me 0, right? So since ax is equal to 0, we already know we have to prove that 2x ax is equal to 0. Since it's actually simple thing. If you plug the 0, ax is, we know ax is 0 already. If you plug this 0 right here, it's going to give you 0. Therefore it's closed under addition. So it's passing the second test. To prove it's closed under scalar multiplication, we have to take a scalar value. So let's say alpha is our scalar quantity. So if it's alpha belongs to S subspace, let's see. So if alpha belongs to S, then first of all we know ax is 0. So if I take this same thing, a1, a prime 2, a prime 2, a prime 3, a prime 3 until a prime k. So if I take this one and a2 a3, so we know this one already, this is ax is equal to 0. If I take this would be x is equal to 0. So in this case, if I multiply this one by alpha a1 alpha multiplied by alpha, so alpha a1 alpha a prime 2 to alpha, okay, alpha a prime k, so alpha a1 a2 alpha a3, and this means alpha ax should be equal to 0. Since we have ax is 0 already, if I substitute a 0 for ax, I will get 0. Therefore this is closed under scalar multiplication. So it's closed under scalar multiplication, it has 0 element, it's closed under addition. Therefore the answer is yes, it's a subspace of Rn. So answer is yes, it is a subspace of Rn. So this is the final answer. I hope you guys like this video. See you next time.